Hello, I am Bob, and this is the Home Bitcoin Immersion Mining channel. In this episode, I'm going to get into exactly what is going on inside these mining machines and why Stratum V1 and Stratum V2 might matter to you as a Bitcoin miner. So with that, let's get started. But before getting on with the video, I want to mention some sponsors of the channel, the first being Brains. Now, with the recent halving event, overnight it could become twice as difficult to be profitable as a miner. Now more than ever, it is critical to get the most out of your mining hardware. And one of the key tools you have to increase your mining productivity and efficiency is the selection of the operating system running your miner. And one of the best options out there is the Brains OS Plus firmware. It's easy to install, easy to use, and they are constantly making updates to support all different hardware models. It has awesome features such as immersion mode, auto-tuning, and dynamic performance scaling, giving you everything you need to get the most out of your mining hardware. And if you use the Brains OS firmware along with the Brains pool, the pool fee is completely waived. So when you are setting up your next miner, give the Brains OS Plus firmware a try. Now my next sponsor is Scott's Crypto Mining and the Build-A-Mine Bootcamp. In the Build-A-Mine Bootcamp, you'll learn everything you need to know to launch your first megawatt of Bitcoin miners in less than 3 months. The Build-A-Mine Bootcamp is taught by Scott himself, and you'll be joined by other entrepreneurs and business owners like you who want to learn how to stack more sats faster through Bitcoin mining on an industrial scale. To get in on this fantastic opportunity, just click the link in the description below. And last up is a brand new sponsor of the channel, Altair Bitcoin Mining Solutions, which is a perfect match for home mining. Altair is your one-stop shop for any mining hardware you might need. They have everything from the latest and greatest miners to every hashboard, cable, and part you might need to repair your existing hardware or build your own 120-volt home-built miner. Altair has years of experience working in the Bitcoin mining industry, including running their own Bitcoin farm, and they've worked with all different scales of mining operations. Altair is based in the US and has top-rated customer support. And so if you have any question about anything at any time, they are there to help you out. Altair is a huge supporter of the home mining community, so if you're looking to buy your next miner or miner parts for your home setup, check out their website at the link below. You'll find pretty much everything you'll ever need. Okay, so in Bitcoin mining, we buy high-priced, high-performance computer servers that are full of ASIC chips. And each of these chips has been specifically designed to do only one thing, and that is to execute a single computational algorithm over and over again as fast as possible. And that algorithm is the SHA-256 hashing algorithm. But what exactly does this SHA-256 hashing algorithm actually do? Now, there are a ton of websites, YouTube episodes, and other resources out there to learn everything you'd ever want to learn about the details of the SHA-256 algorithm itself. So I'm just going to cover enough of the basics to understand how this algorithm works with Bitcoin mining. Back in 2001, the NSA developed a series of secure hashing algorithms, one of which is SHA-256, which gets its name from the output, which is 256 bits long. Now, this algorithm has a couple really cool properties. First, you can give it an input of any length, and it always gives an output of exactly 256 bits or 256 ones and zeros. You can give it a single number, a sentence, an image data file, an entire book. It doesn't matter. It will always give an output of exactly 256 ones and zeros. Second, that list of 256 ones and zeros is completely unpredictable and random. For example, if I input a simple 3-letter word and then just changed one single letter, I'll get a completely different combination of ones and zeros, and there is no way to predict how that combination of ones and zeros will change. The input and output of the algorithm are completely unrelated. Now, a string of ones and zeros, or bits, can also be converted into a number. For example, here's a string of only 5 bits, which can represent any number from 0 to 31. And so the string of 256 bits coming out of the SHA-256 algorithm can represent any number from 0 to 2 to the 256 power minus 1, which is an unbelievably large number. In fact, if you want to get a feel for how impossibly large this number really is, there's a great YouTube video by the 3 Blue 1 Brown channel. It's only 5 minutes long and done really well. I highly recommend it, and I've got a link below if you want to give it a watch. So we have an algorithm that will take a bunch of data in and output some random number between 0 and 2 to the 256 power minus 1, and we have Bitcoin mining hardware, which is purposely built to run this algorithm over and over as fast as possible using as little energy as possible. So what data is your miner feeding this algorithm, and why is it running the same algorithm over and over again? Well, it helps to take a small step back and look at the Bitcoin network. As you likely already know, roughly every 10 minutes, a new Bitcoin block is added to the blockchain. Now, a Bitcoin block is a bunch of data, including a header, the number of transactions included in the block, and the transaction data itself. And it is this header which is what us miners are really interested in. The header contains a short list of really important information. It includes the version indicator, which indicates which soft fork validation rules are being followed, the SHA-256 output of the previous block header, the Merkle root hash, which you can think of as kind of a fancy summary of the transaction data included in this block, a timestamp, something called nbits, which is kind of a summary of the current Bitcoin difficulty target, which I'll get into a little later, and the nonce, which is a random number. Now, most everything here seems to make a lot of sense, and most of these items seem like fairly important pieces of information. But there is one item here that kind of sticks out, and that is this random nonce number at the end. Why is it here? To answer that question, it helps to look at one of the conditions that must be met to add a new block to the Bitcoin blockchain. And that special condition, which us miners are particularly interested in, is when the entire header of the new block is put into that SHA-256 algorithm, the number created by that random list of 256 ones and zeros coming out of the algorithm must be less than something called the Bitcoin difficulty target. This target is simply a value between 0 and that impossibly large number of 2 to the 256 power minus 1. This target value is controlled by the Bitcoin network, it's changed roughly every 2 weeks, and it is set low enough that it is very rare that the SHA-256 algorithm will output a number lower than this value. And so taking all of this together, this finally gets to exactly what our mining hardware is doing. Our miners run this header data through the SHA-256 algorithm and look at the resulting number. If that number is lower than the difficulty target value, then the header and associated block data are added to the Bitcoin blockchain, and we as miners get the block subsidy reward and any transaction fees. But what if it isn't? What if the output of that SHA-256 algorithm is higher than the difficulty target value? Well, if you remember, one of the cool properties of the SHA-256 algorithm is any tiny change to that input data will create a new and entirely different output number. And this is what that random nonce number inside the header is for. It's just a random number and can be anything. Changing it doesn't change the transactions or the timestamp or anything else really important. But changing it even slightly will change the output of the SHA-256 algorithm, hopefully to a new value that is lower than that difficulty target value. So what our mining hardware is doing is taking the header, running it through the SHA-256 algorithm, and checking the output. If the output is less than the difficulty target value, we found a new block and we get paid. However, if the output value is higher than that target value, our miners then change just that random number and try again. This happens over and over and over again. Change the nonce number, rerun the new header through the SHA-256 algorithm, check if the result is low enough. If not, change the number and try again. Now, this difficulty target value is set super low, so it takes an unbelievable amount of nonce guesses before someone finds a number that, combined with the rest of the header data, gives us a SHA-256 output below that target value. To give you an idea of how many guesses it actually takes, just one of my S19J Pros has a rated speed of over 104 terahashes per second, which means all of the chips on all of the boards working together can execute that SHA-256 algorithm 104 trillion times each second. And that's just a single miner. The total Bitcoin network currently has a hash power of over 600 exahashes per second, meaning there's over 600 quintillion guesses for that correct header-nonce combination executed every second. And even with all of those guesses happening, it still takes around 10 minutes to find a SHA-256 value low enough to meet the Bitcoin difficulty target. When you think about it, that's pretty incredible. Now, because there's no way to predict the output of the SHA-256 algorithm, no one knows which nonce value will make the header pass this SHA-256 output difficulty limit. And this is one of the cool things about how Bitcoin works. Each new block is a new and completely fair game. All miners use the same SHA-256 algorithm to try and guess the correct random number, which, combined with the rest of the header data, results in a low enough number to meet the difficulty target. The more guesses you make, the higher chances you have in finding that nonce number that will work. And this is why us miners are always looking to deploy as much hash power as we can and to do this as efficiently as possible. And if you want to learn more about mining efficiency, hash rate, and hash power, I made a whole episode on these topics. You can find it at the link above. Now, most of us use mining pools to even out the mining process and to provide us with a steady source of mining income. I made another episode where I cover how all of this works, including covering mining shares and share difficulty. I have a link above if you want to learn more. But one thing I didn't cover in that episode is the role of mining pools in deciding which transactions are included in mined blocks. As I noted earlier, us miners just get the header of the block. We take that information and start guessing nonce numbers. But where did that header come from? Who decides which transactions are going to be in the block, and who checked that all the proposed transactions are correct? Well, that's where the mining pool operator comes in. The pool operator decides which transactions will and won't be included in the block and does all the work to fold all of that data into the header, which is then given to us miners. As miners, we have no say in which transactions are or are not included, and this is an important consideration when selecting your mining pool. The pool operator may or may not decide to include certain transactions that certain governments may not like. They may also decide to include or exclude certain transactions containing questionable data, such as inscriptions or other data. And so if you have any strong opinions on these topics, you might want to find out what, if any, decisions your mining pool operator might be making about which transactions they are including in their blocks. And this brings up a recent innovation for running mining pools, which is Stratum V2. Now, what I just finished describing is the way most mining pools currently operate, and this is based on using Stratum V1. To recap on Stratum V1, the pool operator decides what's in the block, and they build the block header, which is given to the miners. In contrast, Stratum V2 will allow each miner to construct their own block templates, which would enable individual miners to choose which transactions and which transaction data are in or out. Each of us miners would then build our own block and block headers. And this invention is super important for the decentralization of the Bitcoin network. Some mining pools have gotten pretty large, and they could use that size to impose a lot of control over how easy it is for certain transactions to find their way into Bitcoin blocks. If more miners start using Stratum V2, this will decrease the centralization of transaction selection, maintaining the decentralized nature of Bitcoin. Also, Stratum V2 has a bunch of other improvements, such as data encryption and more efficient data transfer, so there are a bunch of practical reasons to upgrade. So if your mining pool is currently not using Stratum V2, ask them when they're going to make the upgrade. And if they have no plans, you might want to consider using other pools. Now, this was kind of fun to break away from building hardware and focus more on how Bitcoin works. If you'd like more of this type of content, make a comment below. And if you haven't liked or subscribed, hit those buttons so you don't miss any new episodes coming your way. And with that, bye.